Assalamualaikum and good day to our respected lecturer, Dr. Sukhairi and Dr. Kamaruzaman. We are from Group 8 and today we are pleased to present our mini project entitled Automate Tennis Ball Launcher for Sports Training Application. First of all, let me introduce our team members. I am MAISARAH binti BORHAN, the team leader, and Aqilah, Najwa, QISTINA binti ZAINAL, our electronic designer. Next is HANI binti AMIR MOHAMMAD NAZIM, our mechanical designer. This project focuses on designing and automate tennis ball launcher by integrating mechanical, electronic and control system into a complete mechatronic system. Now, I would like to begin with the project overview. So, why we choose this project? Tennis players need regular and consistent practice to improve their skill, such as ball control, stroke accuracy, and reaction time. However, conventional training usually depends on a coach or training partner to continuously feed tennis balls during practice. This method has several limitations. It increases training costs, limits practice session, and produce inconsistent ball speed and launching intervals. To overcome these problems, we developed an automated tennis ball launcher that is capable of launching tennis balls automatically at a controlled speed and interval, allowing players to train independently and more efficiently. Next, the project has 4 main objectives. The first one, to design and develop an automated tennis ball launcher prototype. The second objective is to integrate mechanical, electronic and control components into one complete mechatronic system. The third one is to develop the mechanical design using Autodesk Inventor and AutoCAD together with the PCB layout using AutoCAD tools. Lastly, to provide a consistent tennis training tool capable of controlling the launching speed and interval. Next, this slide shows the overall system overview of our automated tennis ball launcher. The system is powered by a 12-volt battery, while the user selects the desired launching speed and interval through the input controls. The Arduino Uno acts as the main controller by processing the user inputs and sending control signals to the motor drivers. The motor drivers control the speed of the DC motors and that will rotate the launching wheels, while the servo motor controls the ball feeding mechanism. As the result, the launcher is able to feed and launch tennis ball automatically with a consistent speed and interval. With that, I would like to invite HANI to explain the mechanical design.
Assalamualaikum everyone. My name is HANI binti AMIR MOHAMMAD NAZIM and I am the mechanical designer for our project. Now, I will explain how the mechanical system works and the function of the mechanical components. Firstly, I will briefly explain how the launcher operates. The machine is designed to automatically launch tennis balls for sport training, which is, firstly, tennis ball are first stored inside the hopper, and due to gravity, the balls move down through the elbow pipe into the guide tube. The servo gate releases only one ball at a time, ensuring a smooth and controlled feeding process. The balls then enter between 2 spinning flywheels because the flywheels rotates in opposite directions, which friction is generated on both sides of the tennis ball, pushing it forward at a high speed. The launch speed depends on the rotational speed of the flywheel, which is controlled by the DC motors. Now, I will explain the function of each mechanical components. So, the first one is the base plate, which is right here, it supports all the components and keep all the launchers stable while reducing vibration during process. Next, are the tube support. There are 3 tube support here. These supports hold the guide tube firmly in place and maintain the correct alignment so that the tennis balls travel smoothly toward the launching wheels. The main wheels, which is right here, is used to mount the DC motor and flywheels. It ensures that the spacing between the 2 wheels is accurate, which is very important for consistent launching performance. The guide tube, which is right here, provide a smooth path for the tennis ball from the hopper to the launching wheels. It prevents the ball from getting stuck or moving out of position. Now, this is the elbow pipe which connects the hopper and the guide tube. It changes direction of the ball flow and allow it to move naturally using gravity. The hopper acts as the storage container. It can hold multiple tennis balls, so the machine can continue launching balls without needing to reload after every shot. Now moving on, we have DC motor here. There are 2 DC motors. It rotates the launching wheels by changing the motor speed. The machine can launch tennis balls at different speed depending on the training requirement. Finally, the flywheels. There are 2 flywheels here. Also can be called as launching wheels. It operates in opposite direction. They grip the tennis ball using friction and accelerate it forward to launch the ball toward the player. So that's all from me. Now I will pass the presentation to my teammate.
Thank you, Hani. That concludes all the mechanical design. Now, I would like to invite Aqilah Najwa to continue with the electronic design.
Okay, today I'm excited to take you behind the scenes of our automated tennis ball launcher project and show you how I built the brain of this entire machine, our custom printed circuit board or PCB. To bring this launcher to life, our circuit board acts as a central hub. It features a custom 30-pin dual-row interface to connect smoothly with our Arduino Uno shield. For power delivery, I integrated 2-pin screw terminal blocks for our heavy 12-volt battery input and the high-power dual DC motors, along with the 3-pin header for the servo motor that controls the automated feeding gate. During the routing phase, I had 2 major roadblocks. First, the software default library lacked a footprint for our 30-pin shield connector, so I had to independently research alternative library and successfully made it using this package. Second, the auto rotor initially failed with a 0% completion error. I resolved this by diving into the root layer strategies menu to fix our design rules and manually widen our power tracks to 30 mils so our PCB can handle the heavy motor current without overheating. Now, building this was not easy and I ran into 2 massive challenges. First, when I started, the software library completely lacked a physical shape or footprint for our 30-pin Arduino connections. It completely locked up my design. Instead of giving up, I did some digging, research alternative online footprints, and successfully mapped our pins using a package called this. The second disaster happened during routing. The software's automatic tool completely failed, give me 0% completion error. On top of that, the standard wires were way too thin to handle the heavy electricity needed by our spinning launch motors. To fix this, I had to jump into the software advanced layer strategy menus, fix the design rules, and wrote the path manually. I also widened the power lines to 13 mils. This ensures our physical board can handle this massive motor power without overheating or burnout.
Next, for part mechanical design. One challenge that I faced was assembling the components correctly because some parts become over-constrained. To solve this, I fixed the base plate first and applied mat and flush constraint step by step. Another challenge was making sure all parts fit together, so I adjust the dimension until the guide tube and elbow part match properly. This taught me the importance of careful planning and accurate measurement.
Thank you. Throughout the development of this project, every team member gained valuable technical knowledge as well as important soft skills that will benefit us in our future engineering careers. As the team leader, I was responsible for planning the project timeline, coordinating the responsibilities of each team members, and ensuring that every stage of the project was complete according to the schedule. Throughout this process, I learned the importance of effective communication, teamwork, and leadership in managing a multidisciplinary engineering project. I also improved my decision-making and problem-solving skills by coordinating discussion, monitoring the project progress, and ensuring that both the mechanical and electronic design were successfully integrated into one complete mechatronic system. So, I would like to invite our mechanical designer, HANI, and our electronic designer, Aqilah Najwa, to explain about their lifelong learning in their specialties in our project.
Hi, I'm Aqilah Najwa as electronic designer. This hands-on design experience taught me that real-world engineering is full of unexpected software bugs and footprint errors. Overcoming this challenge independently really boosted my confidence to learn advanced engineering tools on my own. In a fast-changing field like mechatronics, the ability to self-teach and problem-solve is a vital lifelong skill that I will carry directly into my future engineering career.
Next, for part mechanical design. This project taught me that engineers must continuously learn new software and improve their skills. By using Autodesk Inventor, I improved my CAD modeling, technical drawing, and problem-solving abilities. This skill will help me create accurate engineering design and prepare me for my future career.
Thank you, Hani and Aqilah. So, overall, this project not only improved our technical knowledge but also strengthened our teamwork, communication, critical thinking, and adaptability. Most importantly, it taught us that continuous learning is essential for engineers to keep up with new technologies and successfully solve real-world engineering challenges. In conclusion, the Ultimate Tennis Ball Launcher was successfully designed as a mechatronic system for sports training applications. The project achieved its objective by integrating mechanical, electronic, and control system into a complete design capable of launching tennis ball at controlled speed and interval. Throughout this project, we gained valuable experience in using Autodesk Inventor, AutoCAD, and OrCAD to develop both the mechanical and electronic designs. This project also improved our technical knowledge, teamwork, communication, and problem-solving skills. For future improvements, the system can be enhanced by adding features such as automatic launching angle adjustment, wireless control, and multiple training modes to provide a more flexible and realistic training experience. With that, we have come to the end of our presentation. Thank you for your kind attention. We sincerely welcome any question, comments, or suggestion from the lecturer and our audience. Thank you.